My name is Taruna Namdev, and I'm currently pursuing my master's degree from RVSKVV University, College of Agriculture, Indore. My topic is climate change and adverse impact on Indian agriculture. As we all know that India is the second most populous country in the world, and Indian economy is majorly dependent on agriculture sector. On the other hand, agriculture is directly, indirectly related to the climate. Today's big challenge is to feed more people than ever by using the lesser agricultural land area. In addition to that, adverse climate condition is the new level of complexity and challenges by affecting the crop production, productivity, and food insecurity. So, the objective of my presentation is to know more about the adverse impact of climate change on Indian agriculture, as well as to discuss various methods for solving these problems through various research and innovations. Here, I want to discuss some problems that arises due to the climate change. Due to the sudden change in temperature, the production of rabi maize decreases in the Bihar state of India. As a result, many companies closed, unemployment increases with increase in food crisis. If the temperature is very low or very high, there is no fertilization, thus affect the fruit set. Madhya Pradesh is also known as the soya state because of its highest production in soybean. But due to the high rainfall at its harvesting stage, the production reduces, so that the farmers have to suffer a very heavy loss. Rainfed rice yield are projected to reduce 2.5% in 2050, and wheat yield projected to reduce by 2.5% in 2050. So these are the some problems that rises because of the change that leads to the instability of the monsoon. So that crop is affected by biotic and abiotic stress. Crop production decreases and the growing population have to face the challenges of food security. So here, let's discuss about some methods developed by various research and innovations to solving these agriculture problems. Number one, role of genetics and plant breeding. So plant breeding has profound impact on food production and it will continue to play a vital role in food security. Plant breeding is relied on the presence of substantial genetic variation to address the maximum genetic yield potential of the crop and adaptations of these variations through effective selections for improvement. The development of superior varieties, climate change resilience crop is necessary important for increasing productivity with parallel to increase the human population. It helps in the improvement of crop plan for quantitative and qualitative traits and the improved resistance crop technology against biotic and abiotic stress. Second method is use of biotechnological applications. It is difficult to overcome the challenge of climate change in the absence of integration of biotechnology into improvement and enhance the crop productivity. Nowadays, genomic research is playing a vital role in crop improvement, particularly in identifying genetic variability and desirable trait as well as the character of different crop genetic material for abiotic and biotic stress. Genomic editing is playing significant role in transmitting insertion and deletion of new sequence at desired location in the target genome. Therefore, conventional crop plant improvement should be integrated with marker assistant breeding process to address the serious challenges of the world through enhancing crop genetic improvement. To achieve fast and agricultural advancement in terms of production and productivity, in the short period of a time, the integration of marker assistant plant breeding is very crucial in the future world. Plant breeding and biotechnology is dealing with biological traits which can be transmitted from generations to another for further improvement against climate change that adversely affect the crop plant. Third method is agronomical measures. So agronomical measures, the integration of conventional plant breeding with advanced agronomic practices had played a vital role in achieving tremendous genetic gains of crop yield. The combined utilization of improved variety with irrigation, mechanization, agriculture tools, varietal selection, and cafeteria approach, managing planting time, improved soil health, efficient water management, use of resources conservation technology, energy conservation techniques, and new energy sources for agriculture. Here, the analysis is In India, Indian National Agriculture Research System and various ICAR Institute and state agriculture universities are making concerned effort over the years for developing genotype of different crop with enhance the tolerance to multiple abiotic situations. Development of various climate resilient crops varieties along with other suitable adaptations and mitigation strategies will help to overcome the adverse impact of climate change by the yield losses under stress condition, like the development of drought tolerant variety of chickpea, IC alpha 14 and BGM 4005 that were developed by transferring QTR hotspot gene from the donor chickpea variety ICC 4958 into leading parental chickpea variety DCP 923 and PUSA 362. Built and sterility mosaic resistance variety of pigeon pea, early maturity variety of soybean, and disease resistance variety of rice and heat resistance variety of wheat, and many more. With the rising annual temperature affecting crop yield and cereals like wheat, agricultural scientists at the Indian Institute of Wheat and Barley Research are researching the development of wheat variety that are resistant to heat, DBW 187 and DBW 387. With that, the government of India also took several initiatives for formulating most efficient mission aiming to combat global warming and for climate change adaptation. All these missions implement package of several technology developed by ICAR, like various schemes like the National Mission on Sustainable Agriculture, Pradhan Mantri Krishi Sinchai Yojana, Parampragat Krishi Vikas Yojana, and many more. So the impact is that India has made significant in agricultural production in recent decade, including the introduction of high yield seed varieties, increased use of fertilization, and the use of improved genetic agronomical practices. The agriculture and allied sector grow at the rate of 3.69 during 2020 and 21. As per the fourth advanced estimation for 2020 and 21, the total food production in the country is estimated record 308.65 million tons, which is 11.15 million tons higher than the during 1920. The oilseed production in India has grown by almost 43% from the last few years. India is projected to maintain a high per capita vegetable oil consumption growth of 2.65% annum, reaching